In the last video, we started sketching the graphs of rational functions, and we saw some functions that only had one vertical asymptote. Now we're going to look at functions that have more than one vertical asymptote. So here, we're going to look at the function f of x equals 2 over x squared times x minus 2. So, first thing you want to do is make sure that your function is in standard form, numerator and denominator. Numerator is fine. Denominator, if you multiply it out, you get x cubed minus 2x squared. So now we want to see about our intercepts. Do we have a y-intercept? So if we evaluate our function at 0, we'd have 2 over 0 cubed minus 2 times 0 squared, which would give us 2 over 0, which is undefined, which means we have no y-intercept. So then we want to see, do we have an x-intercept? To see if we have an x-intercept, we just need to take the numerator and set it equal to 0. So here we'd get 2 is equal to 0, which cannot happen, so we have no x-intercept either. So then we look for our asymptotes. For our vertical asymptotes, we take the denominator and set it equal to 0 and solve for x. So we get x cubed minus 2x squared equals 0. We could factor that x squared back out and say it's x squared times x minus 2 equals 0, which means that x squared equals 0 or x equals 0, x minus 2 equals 0, or x equals 2. We have two vertical asymptotes. So on our graph, at x equals 0, we have a vertical asymptote. Not actually a part of our graph, so we make it a dotted line. And then at x equals 2, we also have a vertical asymptote. Then we want to know, do we have any horizontal asymptotes? So we look at the degree of the numerator and the degree of the denominator. Here, degree of the numerator is 0, degree of the denominator is 3. So numerator is less than denominator, which means that y equals 0 is a horizontal asymptote. So our x-axis here. So this is what we know about our graph. We don't actually know any points here. So that's what we want to find next. We want to actually plug in some points. Remember, use those vertical asymptotes as guidelines for splitting up your graph. So if we have two vertical asymptotes, we really want to look at 3 different pieces. We want to look to the left of our vertical asymptote. We want to look in between our 2 vertical asymptotes and to the right. So if we look on the left, we'd be looking at values like -1, which would give us -2/3. And -2, which would give us -1/8. So we can see that we're going to be coming up towards this horizontal asymptote and going down towards this vertical asymptote. If we look in the middle, between our 2 asymptotes, I know you're not going to like it because there's only one whole number in there, 1. When you plug that in, you get -2. If we go for a half, 0.5, you get -5 1/3. If we go for 1.5, we get about negative 1.7. So you may go, hey, I kind of think I know what's going on here. As we go this way, it looks like we're going down, but what's happening here? So you probably want to go for another point. So between 1.5 and 2, we have like 1 3/4 or 1.75. And we get negative 2.6-ish. So we come back down this way over here. So you always want to check and see what you're doing in there, because it is possible for our functions to actually cross a horizontal asymptote. Vertical asymptotes we can't touch, we can't cross. Horizontal asymptotes are guidelines for us, but we can cross them. So always double check extra points in there. And then on the right side of our graph, if we look at some values over there, we'd have values like 3 and 4. 3 would give us 2/9. 4 would give us 1/16. So we'd have something like here. No, that's not. Maybe more like here and down here. But you can see that we're going to be coming up towards this vertical asymptote and down towards our horizontal asymptote.